Language models are biased. They replicate gender stereotypes, as shown here with professions, and they have a gist of other issues. So, how can we mitigate this, or at least try to reduce those stereotypes? For that, we first need to understand where the stereotypes are coming from. The common setup for language models is to find a big pile of data somewhere and then start training on this with a masked or causal language modeling objective. In both cases, the task is to predict a word or a token given the rest of the sentence. Now, the most common data sources are scraped from the internet, but also old copyright-free books are popular. A lot of other sources exist, but these are free and available. So we use data with issues. Some social groups are underrepresented or not represented at all, and language models like BERT pick up on this and replicate this behavior. So approaches until now try to fix the data, with counterfactual data augmentation for instance. Counterfactual data augmentation works with a list of substitutions, for instance he and she. Every sentence with an occurrence of he is then duplicated and he is replaced with she. This pre-processing should change the data distribution, and the model should, after pre-training, also predict less stereotypical words. However, using counterfactual data augmentation to create, say, a new BERT model without gender stereotypes, that's quite expensive. The model has to be trained from scratch, again, so all the work with the original model is basically thrown away. And we can do better. Our method doesn't change the training data, but modifies the predictions of the masked language model. We can use all the same CDA substitution rules, like pronouns and names or professions. We kept it simple and we focused on the pronouns. These modified predictions are not so useful on their own because we typically use a language model to do some other task by fine-tuning it. And the weights of the language model haven't been updated yet. However, we can use these modified predictions as a rich training signal. Each token has a certain probability, so we can use that to train another model, even a smaller one. This is a process called knowledge distillation and generally results in quite performant models that are a bit smaller, like have the number of parameters. That's more efficient for training and inference, and it needs less storage as well. We tested this on BERT, an English model, and on Robert, a Dutch model. Both seem to have less stereotypical predictions and the performance only took a minor hit, but is still on par with the distilled variants without fairness. So, this is a promising method to create fair language models, although the reliance on substitution rules still makes it quite brittle. Eliminating that is future work. And for that we released our code and models on GitHub. You can also find more information on the paper at this URL or via my Twitter profile.